So predictors for lending rate or interest rate are predictors for our linear regression model. So remember that we can have different types of data types for predictors, both numeric and categorical. And here we have some categorical data. Oops. Like the categories, either the income is verified or not verified, and then we have some continuous data. We also have some binary data. This can be a predictor. In this case, we're going to see if the or explanatory, if the bankruptcy can be explain the level of interest rate. What happens is we have the actual data. So this is the actual data frame. The data set is here. We load it into the regression algorithm, and then what the regression algorithm does is give us the betas, the intercept, and the error rate. And in this case here, after we fed the data into it, we got a coefficient for the bankruptcy variable of 0.74, and that means that, and that's a binary variable, so it's just 1 or 0. So the way we interpret this is that every additional unit of bankruptcy increases the interest rate by 0.74 percentage points. And this scale here, the data type of the dependent variable is the one we use to explain here. So I'm saying percentage points because the interest rate is in percent, but it doesn't increase the interest rate by 0.74% because that would mean something else. It raises it by 0.74 percentage points, meaning you add 0.74 to it, where it's different than to say 0.74%. And this is compared to the ones, so if a person is bankrupt, the interest rate is 0.74 percentage points higher than the people that are not bankrupt. That's how we interpret. That's a better way to say it. The predictor variables can be categorical or numeric, as mentioned, but the dependent variable in the regression has to be continuous, and it actually cannot be just integer or count data like 1 or 2 or 3 and 4. It has to be able to be decimal, and we use different kinds of regression when it is not continuous. But for our purposes, we might be able to fiddle around a little bit with that. Interpreting categorical predictors. So this is just kind of a reminder on how we interpret categorical predictors. Remember, it's always compared to the value that is not there. So bankruptcy is 1 and 0. So here it means that's when you do have bankruptcy, this is the value on average, controlling for all the other factors, and here's there's not, but when you do have it, compared to the non-bankrupt people, the people who have bankruptcy have 0.74 percentage point higher interest rate. Now, and there's some about that. Just remember, we're talking always about on average compared to the other one, the reference level. And the same goes when we have multiple categories. So for example, we have like income type, and there's actually 3 categories. But when we see on your regression results, you're going to see only 2 categories, and those are each of them are compared to the reference level. So the verified income source, verified people have interest rate that's 1.42 percentage points higher compared to the one not listed here, whatever it is called. I don't know if I have it here. I think it's income verified, income source verified, and not verified. So don't compare to the ones that are not verified. And when we have a big model with multiple, or any model that we have more than one predictor variable, remember all of them are controlling for the other ones. So that's one of the usefulness also of the model. So each coefficient, also sometimes called slope or estimate, is the impact of a unit increase of the explanatory variable on the dependent variable. And it's pretty straightforward to interpret. Each coefficient has its own standard error and p-value, so that's the amount we can assume it will be the case given 94 or 95% confidence. It's over here, standard error 0.1. So for example, we can assume that the value is 2.5 plus 0.117 and 2.5 minus 0.117 within 95% confidence. And this actually is statistically significant because p is less than 0.05. So you want to like make sure that all of them are statistically significant as well. Each coefficient in the model is controlled for all the other variables. Variables are added or removed will likely change the value of the each coefficient and also of the whole model. We've kind of gone over this in previous videos. So next, we're going to talk about evaluating the whole model with R squared.